and welcome to Pertemps Engineering Podcast. I'm Kelsie and I work as a senior recruitment consultant at Pertemps, helping brilliant engineers find exciting jobs. And today we're meeting someone really exciting. Katy Milne from the Manufacturing Technology Centre is an engineer who works on amazing projects to help people every day. We're going to find out how Katy got started and what makes engineering cool and what a day in Katy's world looks like. So welcome, Katy.
Hi, Kelsie. It's lovely to meet you.
So if you could just tell us a bit about yourself, what it is you do, the industry that you're working in.
So I work in research and development, and we help companies in lots and lots and lots of different industries to develop how they make things. So there's lots of people who help develop the actual products. And that could be anything from bridges all the way down to hair straighteners or your mobile phone. But we don't think about the product side so much. We think about how you're going to make it. And some of the coolest technology is about how you make the thing. So that's my job. And I work with companies in the automotive sector, making cars, in aerospace, making aeroplanes, in space, making satellites. And I also work in companies in the transport infrastructure sector. So companies who have to think about how they maintain bridges and roads as well.
So a very broad range of things that you're designing. Going back to aerospace, automotive, are you engineering the parts that go onto them or the final product, let's say?
For us, it's all about how you make them.
Right.
So if I give you an example, we're working on a project with an automotive company, so a company who supplies bits into cars to help them make their batteries better. So we have lots of lasers at our facility, and we use those lasers to kind of weld metal together. And that's a key step in making big batteries for cars or for trucks and things like that. And we're trying to figure out how to make those processes better, more efficient, faster, that type of thing.
And was this something that you knew you always wanted to do, sort of, when you were sort of coming from sort of maybe sixth form or university? Was this sort of career what you were working towards?
I guess everybody's journey towards engineering is different, right? So when I was a little girl, I wanted to be an author, first of all. I think then I figured out that maybe I wasn't good enough to do that when I started secondary school. And I loved science. I loved it, and maths. And I therefore started looking at what careers I could do if I was good at science and maths. I also was really passionate about space. It's quite geeky, but I went to a thing called Space School, which I think still runs today. It was down near London then, but I think now it runs in Leicester. So I went to Space School, and that was great. I found out all about astronomy. I found out about space geology, so people who try and figure out what different planets are made of and understand the rocks and gases that make them up. And I found out about engineering. I got the chance to go to a satellite factory, and it was just so cool. So it was then that I was like, yeah, I want to be an engineer. And I think I decided I wanted to go into research a little bit later. So that was probably when I was in my last years at university. I decided I wanted to go into research. And so to get into research, I decided that I'd become a doctoral student. So I'm an engineering doctor now and work in engineering research. But you don't have to be to work in engineering research. So the people I work with have come from all sorts of backgrounds. So we've got people who've gone through the apprenticeship route as well, all the way up to professors. And it's an incredibly inclusive environment where you can start almost at any point and end up anywhere.
And I take it where you are at the moment, this isn't sort of the end for you. I bet in years to come there's going to be different avenues that you take. And I've seen on your LinkedIn over the past sort of 10 years, you've done sort of secondments in different industries, would you say?
Yeah, the secondments that I've done I started my career at Rolls-Royce, which is a major employer in the Midlands, and then moved after my doctorate, because I was there as a student. I moved after my doctorate to the Manufacturing Technology Centre, and they've been a great employer, and they've allowed me to go on 2 secondments in the last 4 years. So both of those have been into agencies really that have been responsible for distributing funding on behalf of UK government. So one of them is the Aerospace Technology Institute. So that organisation directs the R&D funding for UK aerospace and sets its technology strategy. And then I also did a comment for something called the High Value Manufacturing Catapult, and that organisation works with my centre, Manufacturing Technology Centre, and 6 other centres from across the UK, all over the UK. So Scotland, up in Glasgow, Sheffield. We've got a sister centre just down the road in Warwick Manufacturing Group. There's one up in Broughton. You know, there's like many locations across the UK. And I got to work in the central office of that, working kind of at the network level, which was really fascinating to see the range of things that people were doing. In terms of the sector, both those secondments were working on hydrogen, which is one of the future, fuels of the future, I suppose, as we wean ourselves off fossil fuels and oil. So that was really exciting too.
It's very interesting. It's sort of things you just don't realise go on in day-to-day life when you're going about your day as normal. Is there any sort of exciting projects that you can think of off the top of your head the last few years that you've been a part of that people, again, may not realise are a part of day-to-day life?
Yeah, crikey. We work on so many different things. So I'll just pull out a few. One of my favourite projects. So I've done lots of work in additive manufacturing. So additive manufacturing's also known commonly as 3D printing. I've got a couple of things to show you if you like. So this was printed by one of our partners. They're called General Electric Arcam, GE Arcam, and they printed this from titanium.
Oh my God.
So that's from a 3D printed machine. And then I've got something else which isn't quite as cool, but has also been 3D printed. But it's an aeroplane shape. So here we go. So I work on aeroplanes. So this is a little aeroplane that I was printed on one of the projects that I worked on along with the others, called Fly Zero.
And is that metal as well?
Yeah, I think from the weight that it might be aluminium, that one. The cool thing is that you can 3D print incredible shapes in metals. It's a process that allows you to create shapes that are kind of a bit more organic. So if you think about things like trees or make, like honeycomb structures and that kind of thing, you can print those things, and there aren't other ways of making them at all. There are no other ways of making them, which opens up freedom for designers. So some of the people who have been using these technologies most are often artists who's creating incredible dresses or jewelry. I think there's 3D, you can get things 3D printed in the jewelry quarter in Birmingham, for example.
I had no
But
idea.
I've been working, yes, you get your own 3D printed wedding ring. But I was working on 3D printing or additive manufacturing, as it's kind of formally known, in the aerospace sector, and helping them figure out how to print parts that be used in really quite harsh environments. So inside a jet engine, for example, that are 3D printed. Now, if you're making a ring or a necklace, it doesn't matter if deep under the material there's a few little holes, but if you're putting it on a jet engine, then it matters. So we were trying to figure out how to make sure that this was a really robust process that could be used to make good parts. And we helped some companies make some of the parts that are now, or develop, I should say, because we're in research. So develop some of the components that are now actually flying about day to day on aeroplanes, which is a thing which makes us feel really proud, because it takes a long time to get a disruptive technology like 3D printing into a highly regulated, safe industry like aerospace.
Oh yeah, I mean, I'm just still amazed at the fact you can 3D print metals. I mean, I've seen few 3D printers with companies that I work with in the area, and I've only ever sort of come across plastic and those sorts of materials. I was not aware that metal was something you could 3D print, which is honestly, I'm sat here in my mind is blown.
Well, plastic's quite developed. So I've got a plastic 3D printer downstairs, which the kids use to, print things with, print toys with, or print little trophies with, that kind of thing. But yeah, metals, and you can print it in ceramics, and some of the cutting edge is about doing things like printing different materials together. So then could you print a bionic arm, for example? And in medical field regions, they're trying to print tissue. So, for instance, could you print a throat, for example, so that somebody who'd got a diseased throat could have a new throat
Oh my gosh!
fitted?
You know,
That kind of
I'm
thing.
obsessed with
It's
Grey's
incredible.
Anatomy, and that one of the episodes on there, they were trying to 3D print like arteries for things, and I was
Exactly.
like,
Yeah.
I felt like I was actually learning something watching it, because I wasn't actually aware at the time whether they were making this up for TV, or that is this something that you actually do in medical. And the more research I've done on it, this is actually a thing that happens, and you just would never think
Yeah.
that.
Yeah,
Crazy.
it's amazing. We don't work so much in the because we more metals and ceramics. We don't do biological tissue. But the point is, the technology is kind of the same. It's all really using print heads, so different types of print heads, and computers to control those print heads to get these incredible complex geometries. And yeah, it just opens up lots of things that we could never do before. I've been really proud to work on that. And then we work on like completely different projects. So, I'm a manager now. I don't do the research myself. So I did do the research on that stuff on 3D printing with those aerospace companies. But the teams who I work with at MTC are still doing some incredible stuff. And my job's really to help them apply it and work with industry. So one of the things that's most interesting to me, because my background is inspection, is that the inspection team at MTC are using, if you go into the security area of airports, they've got those baggage scanners.
Mhm.
And those baggage scanners, like, they're getting more and more used, aren't they? So you can scan your baggage now without taking your laptop out. Like, you're going through a scanner and you're standing like this. So those technologies are using something called backscatter X-ray. So you basically apply a very low dose of X-ray to the bag or the person, and you're looking for what comes back to create the image. So we're using that same technology to do things like inspection of bridges or railway arches, that type of thing, working with some really important companies in the UK. And the guys have worked with the people who make the imaging systems on the one hand, and the people who make the robots, to be able to kind of crawl up these tunnels. And they use it to make inspection much safer. So rather than having a person inside that tunnel doing a job that's like fairly repetitive for many days, can we get them working with a robot so that it's safer for them, it's quicker, so less downtime, which means that you can use the tunnel, the robot. You see all these types of things, and I mean, some people might find that dry, but I absolutely love that stuff. I love taking imaging devices and using them to. It's like Superman, Clark Kent. He can just look through
Look through
things, can't
anything you
he?
want.
Exactly.
Which is quite interesting.
I just love that. I love taking these imaging devices and being able to kind of look through the wall, but use it to create some real impact and improve people's lives. It's
See,
great.
I'm quite nosy personally, so I would just love having a device there and just like, okay, what's inside this?
Exactly. Yeah. Although you might be disappointed when it's just a few pipes, but still.
So just from those two projects alone, it seems to me that sort of in your position, and I'd say in any type of engineering role, is it safe to say sort of no 2 days are the same?
Yeah, yeah. I mean, that's the absolute best thing about engineering, is it's really broad, like massively broad. You can start as an engineer and you can end up in marketing, you can end up in possibly recruitment, you can end up in project management, you can end up in design, you can end up in manufacturing like me. You could be anywhere from like a technician all the way through to the CEO of a big FTSE 100 company. Like the the pathways, I guess, are endless, and that's really, really exciting. And I genuinely believe that engineering is one of the most inclusive sectors, in the sense that you can come from any background, you can enter any level, and you can get right to the top if that's what you want. And on the other hand, if all that drives you is just being really interested every day, then it's a job where that interest is kind of never ending, really. And I absolutely love that. I love engineering.
Oh, that's good. I can imagine, especially sort of people coming fresh out of university or being like mid-20s or, or even up to sort of like late 30s and being in a career where you're sort of not feeling stuck. Because I feel like a lot of people can get to somewhere in their career and think, right, I can't see where else there is for me to go now. I feel like a job like engineering, your opportunities are endless, and to jump from different
Yeah.
industries and different sectors of engineering. And actually, I always say to people, up until I got rooted in engineering, to actually explain to someone what an engineer is, I think the explanations are kind of endless, because it just depends on what type of engineer you are, what side you do. I always just used to think it was just making things, and when people used to tell me that they were an engineer, I was just like, I have no idea what you do. And I just think the more and more I learn about it as I get older, it's such an interesting job, and it's just I come across different types of engineers now. I mean, in the more recent years, we've got things like AI engineers and things like that. And I just feel that there's always going to be new engineering roles come up, so there's always new things being
There
designed.
is, yeah.
Yeah,
And one of the big groups we've got at MTC is an artificial, a digital team. So they're doing things like artificial intelligence, how we connect manufacturing machines so that we can get the data off it. How does all the software work together? How do we use these amazing digital tools to like design future factories, to figure out how supply chains work and all this kind of thing? So there's about 100, I think, of those digital engineers at MTC. And it's like that's one of the really big cutting edge areas for us, is how do we link the hardware, the machines, to this new digital world? How do we leverage digital for the future? So it's really exciting. And you know what is, I think, great for in, ter- in terms of the digital engineering, is if you just go down a kind of computer science route, there is a chance that you'll be in front of a computer, if that makes
yeah,
sense. But with engineering, and if you kind of go down, so one of my best friends did computer science and then went into electrical engineering as a postgraduate degree, and then was the chief technology officer of a startup, which they've now sold. So really incredibly successful woman. But through that, she's got exposure not just to the square that is the computer screen, but to all of the physical stuff that's like actually real, that they're interfacing with and controlling. And it just makes everything, I think, a lot more tangible, if that makes sense.
no, it does. Yeah. Sort of going back to being a female in engineering. Is there sort of
Yeah.
anything that shines out to you? Maybe even going as early as secondary school, doing your A levels or BTEC or whatever it was that got you into university, to your early career and even today. Is there any sort of challenges that you feel you face as a female in engineering that sort of shine out to you?
I think I was lucky that I wasn't conscious when I chose engineering that it was a thing that girls shouldn't do, if that makes sense. So I think there's some bias, like this is jobs for the boys somehow. And my parents they never spoke about that. I didn't know it was something I shouldn't do. And then I'm a little bit of a stubborn soul. So when I turned up and it was all boys, in the application process, my reaction was like, oh, okay, a chance to beat all these boys. So rather than putting me off, when I finally realised, if that makes sense, rather than putting me off, it almost motivated me. But what we don't want is for women who would feel uncomfortable in that sort of male dominated environment to have that reaction. And I think it's changing so much. The proportion of women going to engineering is steadily increasing. It's very rare now for me to be the only person in the room, which happened early in my career. The culture has shifted in lots of different industries that I've engaged with. So it's kind of, less of a bro culture, more of an inclusive culture. So I think and hope that many barriers are going, but some still remain. There's not equal numbers of men and women entering engineering yet, and there's not like lots of senior female engineers. That's probably the last thing. But I find it really weird that there's not more female engineers, if I'm honest. Like, but engineering is sorting out everything that everybody uses all day. It's like got the biggest social impact, in my view, of
Oh, I completely agree.
any career. So I find that a little bit odd. And I also find it odd from a work-life balance point of view. So I've heard a lot of women say that they don't want to go into engineering because of work-life balance. And, engineering normally has really supportive maternity pay and maternity leave. It's the case that even if shift patterns are difficult, because they are a thing in some parts of engineering, that there are roles that you can go in. Most roles don't have shift, so I don't understand it. I feel like there must be some biases in society which my family didn't have or push on to me, which are making people veer away from it, really.
Yeah, I think it is the influence on when you are that younger age. I mean, I sort of think now, being sort of in my late 20s, if this was something I had a bit more knowledge about when I was sort of in secondary school, where would I have been today? Because the more I've learned about the sector, it's such an interesting sector and your opportunities are endless. And I think you've sort of mentioned it earlier, your favourite subjects in school, they were maths and science, and then you've got people that would go down the computer science route. So I just feel like majority of subjects in school probably would have some form of link to engineering, really.
Yeah, definitely. I also passionately believe that you don't have, like, you don't have to be good at maths to be an engineer. Surprise. You also don't have to have done those subjects to get into engineering in the end. Did a year abroad in Italy during my degree, and they could have they could have done like concentrating on all arts and still apply to an engineering degree and come across and do engineering. So I think somehow, like, our education system is very structured, and you feel that it's cutting things out, but you don't have to stick to that. Kelsie, you could still change career. Met this apprentice. She was amazing, and she'd actually started her apprenticeship in beauty, and I think she got a year or two into that apprenticeship, and then she thought, I'm not enjoying this, and she changed to be an engineering apprentice. And I met her, and she was like a year or so out of it, and she was having the best time
Oh,
working up at a factory in Liverpool. And I know, so like you can, like that story is so heartening for me, that you've got somebody who's gone all the way from beauty to engineering. It's like, yeah.
linking this to the younger girl that you'd seen go from beauty to engineering, if there are any sort of young girls listening to this now and they're wondering, would engineering be for me? I've got these interests and I never thought this would be a career path that I'd take because I like this. And what would you say to her?
I'd say go for it. I can't give specific advice really on pathways and how to change, but there's so many resources out there to help you with that. You could like go and speak to your local colleges and ask about changing. You could contact the university. There's so many ways in, and I think the one thing I'd say is, don't assume it's super super hard just because you're missing something in your head. There's lots of, what's it called, like crossover courses to help people that are missing that bit. And you don't have to be great at things like maths to get into engineering. I always rib my husband because he's a materials scientist and he hates maths. But you can do it without having like top marks in mathematics or whatever. It's because there's so many different roles, and they just don't all depend on that as a skill set. And the colleges, universities, whatever it is, will help you. I should shout out MTC's training centre. So we're based just outside Coventry, our research organisation, and our sister company is the Advanced Manufacturing Training Centre, which is supported by Lloyds Bank. And they run an absolutely incredible programme, predominantly aimed at school leavers, but I'm sure that they would welcome people from different backgrounds, of apprenticeships, working with local employers, and they're training 100 apprentices a year. And we have some of those individuals then join our company, our research organization, and they're just absolutely amazing. If people are interested, they might be one route.
Awesome. Yeah, I mean, working in recruitment, I mean, I specialise in like engineering and manufacturing recruitment in the Dudley area. And the amount of calls and people I get coming to me and they want this sort of job or they've seen an ad that I've put online and they say, I really want to try this job. And some companies just aren't in positions where they can offer that training, whether that's just due to lack of resource or just don't have the time. So to be in an organisation that solely has that dedicated team to bring that next generation in and maybe I mean doing the training themselves, does this still go through a training provider or are you the actual training provider?
No, the sister company, so the training center, they are the training provider.
Right.
So they're Ofsted checks and all of that kind of thing. Yeah, and they work with a really large number of local employers to place students, and it's just great, isn't it, that you've got somebody who is effectively sponsoring you through your apprenticeship, so that when you come out at the end, you've got a chance of a permanent job. I mean, what an incredible first step on your career, really.
Exactly, and I suppose your sister company with working alongside yourselves, going down that apprenticeship route compared to, say, going through the university route, would you say this is a lot more of a hands-on experience and learning method than sort of reading through books and lectures?
Yes, yeah, it's definitely much more hands-on than the route that I went down.
Yeah.
Also, I would say engineering degrees are really hands-on. So I was building robots, doing materials testing, doing labs with different like pressures and water. We were stripping down engines, so engineering is hands-on, but there's also parts of engineering which are completely just on, using digital and computers most of the time. So it's just so varied, and it's that variation really that's great.
And that brings us to the end of today's episode. A huge thank you to Katy for being a part of our engineering podcast and for helping to inspire the next generation of talent. Your insights and experiences are paving the way for young girls to see engineering as an exciting, achievable career choice right from an early age.
Thanks, Kelsie. Bye.
Thank you.
Lovely
It's
talking to
lovely to
you.
meet you. Thank you so much, and I hope you enjoy the rest of your day.
Cheers.
Bye.
Bye.